Okay, so this is the second, I guess, episode of what's on my workbench. As you can see, I'm still working on the 7800. The RF shield is off now, and that's a very simple board. 7800 is kind of interesting because um, you you have a 7800, which is kind of a stripped down Atari 8-bit computer combined with an Atari 2600. So it has the chips for both. So when you add the S-Video or a composite mod, it adds slightly challenge because there's actually separate Luma and Chroma. There's one is slightly different from the other one, so you got to mix the signals together. So we're not up to that point yet. I'm actually have to make up the board. It'll probably be tomorrow night's video. I'll show how I make up a summing board for it. So the way these old systems work, they had it was just like the 5200. They have one chroma for. Actually, this system has two chromas because it has a 2600 chroma and a 7800 chroma. And chroma is just the color channel of the system of this, and then they have 4 lumas, which is the brightness. So those all need to get summed up together and then fed through just a transistor to amplify it, and then impedance matched to go out into the outside world. And it's actually built into the board now. You'll have there's the lumas and chromas here, and they'll go through a transistor, and those get summed up and then get sent over to the RF. This is the RF this box here is the RF modulator. There's actually a really simple mod if you just want to do a composite. You just pick off a couple points here, you sum them together, and then you have voila, you have the composite out. The composite's already on there. It just gets fed through this RF modulator first. So first things first, what you usually want to do is replace the capacitors on the board. These are electrolytic capacitors. There's only 3 of them on the whole board. There's a big 2200 microfarad and 2 220s. What capacitors do, though, lots of times they're used for basically buffering the power supply circuit. And as they dry out, that smoothing or buffering goes down. So so if you've never soldered before, soldering iron, this guy here. Let's hit the big one first. Some people prefer solder wick. I prefer solder sucker. I guess it kind of depends what you learned on. Sometimes there's just a little bit left over to break off. Because when they originally install the cap, that goes one side. Other. Keep that hot. Alright, so took the cap out. This electrolytic capacitor. How all capacitors work is there's 2 metal layers separated by an insulator. In this case, it's an electrolytic insulator, so it actually can physically dry out over time. There's a new one. If you ever replace caps, just make sure you have the same the same rating. These are both 2200s, and you just want to make sure the voltage is equal or higher. The old one I took out was 16. I'm replacing with a 25 volt. You can always go up in voltage, just don't go down. If you go down, you'll exceed the breakthrough voltage on the insulator, and what that'll do is it'll start breaking down the capacitor. Oh, and always be mindful of polarity. That's the most important thing. So there's a little plus, a little minus on there, and the capacitor has a big minus stripe on the side to let you know, hey, that's the That's the minus. If you hook it up backwards, it'll work, but what will happen is the hydrogen will form inside of the capacitor, and eventually the capacitor will pop and become a nasty little party favor in your system. I still use leaded solder just because you don't have to worry about tin whiskers or anything like that. It doesn't really matter on this board, but on systems with a ton of capacitors, like a Game Gear or Sega Genesis, I tend to leave the leads on, and then I clip them, so I don't want to risk leaving an old cap in or replacing a new cap twice and skipping one. So you leave all the leads long, so when you have all of them replaced, I'm getting good flow on that one. You'll see in the back of this, the surface kind of slightly bubbled up, and that's pretty typical. It's just a masking material, and that tends to degrade a bit over the years. Not a great desolder job there. It's not the way you're supposed to do it. I'm going to try it anyway. So first, you don't get the solder off. You can always resolder it so you get a good flow, heat flow. I tend to turn the iron down a little bit when I'm working on these old boards, because right now I've got it down at about 370C. I forget what the heck that works out to be in the Fahrenheit. A little better. One side I got well. See, one side's moving, the other side doesn't want to go. Sometimes what happens is they bent the leads up quite a bit to hold it in the board when they originally installed it, so it makes it a little tricky getting them back out. Of course, all this stuff is simple compared to trying to work some of the surface mount stuff. Surface mount, you need a microscope and a steady pair of hands, and usually a proper desoldering station. That came out. Just clean that hole up. Okay, so that was a 220. Double check. 220 16 volt. Replacing it with a 220 25 volt. Again, you can see plus minus. Stripe goes to the minus. Plus is the longer leg lead on it. Drops right in. I think one of the hardest ones to do, or most time consuming, would be Sega products in general tend to have a lot of capacitors. They tend to be the hardest because there's just so many of them. And one other cap over here, C61. Yeah, the Segas are kind of a pain because even something like a Game Gear will have something like 31 capacitors, and it's gets a little tedious at times. So if you ever wonder why someone charges so much to replace the caps on it, it's because there's just so many of them. If anyone charges you a lot for like repairing like a Nintendo old NES, they have one capacitor on the entire board, one electrolytic board. They have Mylars in there and stuff, but those don't dry out. Let's see if I got that. Yeah. Came right out. Yeah, so you can see the reason you got to fight a little bit is computer loves to go to sleep. Got to turn that down. So if you look how curved that is, it actually makes it really kind of difficult to pull them out. Alright, so another 220, 25 volt. Mind the polarity. Positive. Indicative stripe. I mean, this isn't always necessary, but it's just going to give you a cleaner signal to work with when you're all done. And since you're in here anyway, you might as well replace the caps. I just take a pair of diagonal cutters. I don't have any flush cutters right now. Are these flush? Yeah, they are flush cutters. Take it back. These are flush cutters. Flush cutters, you can see that's flat. So caps are replaced. So got the caps replaced. It's not perfectly straight. This anal retentive. There we go. Purely aesthetic, works just fine. I just want it to look a little neater. I always try to make my soldering look as neat as the original soldering did, so you can barely tell. I was here, here, and here. Can't really see much difference between what it was and what it is. So I have to go through and start making the board up. What I always do is I print out a paper. I create these it's like a pick sheet almost, a pick packet, a Kanban I think is another word, kind of sheet. So I put in a copy of the invoice, and then I go in and print out. I actually have a lot of the stuff printed already. I print out a copy of the how to actually do the mod. Is if I'm doing the mod, like first, it's like the 5200, I had to draw everything up by hand. This one, there's quite a bit of information out there on the 7800, so I went through and just printed out this old guide. I think it's over 20 years old. How to add this mod. Atari Age is a great resource for this kind of information, and they've so it's kind of interesting. So now I gotta go through and make up the board. Maybe I can start showing you what goes into it, so I don't want to do too much tonight. So this is a rather crazy old looking diagram that I came up with in ASCII of all things. So I could start pulling all the parts for that. So you can see here you have a sink, luma, 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 which is the brightness. This is basically the summing board. So you have a Zener diode running in, and you sum up your sink. How the old NTSC signals worked is you'd have a each line would scan through, so it would go from, it would sweep across, the electron beam would sweep across, and the lumas would tell it was an analog signal to say how bright to light up the elements on the screen. So your sync is basically your horizontal sync to say end the line, head back to the beginning of the line. It's like an old typewriter. It would go, you hit the end of the line, ding, and you fly back, so it would tell it to sync and move it back. So you basically have to sum it up. Then you bias it out using 5 volts, and this works. This is a transistor here. It's just a simple it's a PNP resistor transistor. So you sum it up, you amplify it, then over here sum it. I'll probably end up drawing this in a proper CAD, like KeyCAD or something, so you can actually be useful. Because this is 20 years ago. So you sum it up, you amplify it, and then that heads out. This is your Luma output. And your chroma, you just run through. Like I said, the weird thing about the 7800, it's actually 2 systems of one. So you have a chroma for 2600 chroma and 7800 chroma. So you run them through a 10K potentiometer, and then sum them up through a 1 microfarad cap, and then there's your chroma output. So if you tie those together, you get composite. If you keep them separate, you have Luma and chroma of S-Video, because that's why S-Video looks better, because they separate the color space from the brightness space. And the audio output, again, 2 separate. This weird one here, the 2600 and the 7800 both had a strange quirk. The audio hardware is very simple, and they would actually integrate audio hardware into the cartridge itself for the more. If you play like Pitfall 2, The Lost Caverns, it has a really beautiful soundtrack to it, and Ball Blazer 2 for the 7800, and that's because they actually put the audio on the cartridge, circuitry on the cartridge, and you have to sum it up on it or you won't get any music on it. So that is it for tonight, I think, and I'll start pulling parts. I have a big part bin over there. I have all the different resistors, and I'll pull all the resistors and start populating a board and soldering that up, and you can start seeing that tomorrow. Thanks for watching.